Hello and welcome to this AWS webinar. My name is Ian Massingham. I'm a technical evangelist with Amazon Web Services based here in Europe, and I'm going to be your host for this session. This is the third in our series on DevOps in the enterprise, where we're exploring techniques that you can use to improve the speed, efficiency and effectiveness of software-enabled innovation within your organization. And we're looking at how we can use AWS tools to enable that, of course. And in this particular session, we're going to be taking a look at automating deployments. You may recall in the last session, we talked quite extensively about continuous integration techniques, how this technique can help speed up the rate at which you can iterate through new releases of software and do that with a greater degree of reliability. Using this idea of continuously practicing through automation, the integration of your software components that comprise your product. And then later on we talked about using AWS tools like AWS CloudFormation to automate the deployment of that continuous integration environment. And we did mention in that session that we would come back and discuss continuous deployment this week, which is what we're doing right now. So, what is continuous deployment? Well, a mechanism for getting from your CI environment, where you produce deployment artifacts, into your test or production environment through a series of repeated deployment activities, which are continuous because each time a build is integrated and tested and integrated, it is then deployed into production or into test and made available obviously for testing or for production use. And it's the automation that's key here, this idea that you're going to use this automation to give you deterministic and reproducible results, and ultimately to give you faster reproduction of time-consuming tasks, so you can step up the beat rate at which you deploy your software, deliver smaller incremental innovation to your customers more quickly. That can enable you to do more rapid A/B testing, or simply to evolve your product more rapidly so that it meets the needs of customers more accurately and in a more timely manner. And a great example of an AWS customer that's doing this today is an organization called SmugMug. So this is an innovative photo sharing service that has a lot of high value photo sharing features, as befits a service that is targeted solely on one particular problem, one particular use case. And they've done something really cool with deployment on AWS, which is to turn the deployment process into a physical activity. And here you can see a photo of their deployment system, this push button deployment system, which is built using an Arduino, believe it or not, wired into those deployment buttons and connected to headers on the Arduino. And that gives them a key, looking a little bit like a weapons arming system, an arm, and a deployment model. This is fully documented actually on their technical blog, which you can find at sorcery.smugmug.com, which will give you a lot more detail about how they built up the Arduino and how the Arduino is integrated with AWS services to enable SmugMug to take their deployment to a fully automated process, which is so simple it can be activated just by pressing a button. And in basic terms, this is what happens in the background. So you're producing your artifact from your CI platform. In our case, we're going to be using Jenkins in a demo we're going to show you in a few minutes to do that. You store those artifacts in a repository or repo, and in our case, we're going to be using Amazon S3 as that repository. And then you deploy the architect from your repo into your target environment. And in our example, we're going to be using CloudFormation to drive that deployment as well. So we're going to base our model here on AWS services that can fulfill those three scenarios: the Jenkins environment built using CloudFormation in the last webinar, the storage of those artifacts in S3 using Jenkins, the Jenkins S3 plugin, and then deployment from the repository directly into a target environment using CloudFormation. So let's take a look at that demo now. In the demo from the last webinar in the series, we used CloudFormation to set up a continuous integration environment, and in this demo we're going to show you how to use this environment to run a build, place the artifact or artifacts created by that build into S3, and then use a target environment to pull down the artifact and deploy the application. All of this is going to be done hands-off using AWS CloudFormation, and we're going to use a very simple target environment here that just comprises a single EC2 instance, and that itself is going to be created using CloudFormation, as I've said. So today we're going to show you how to build and deploy the sample Rails application that you can see here by taking a tour through the environments that are involved and the configuration parameters that we've used in each of those environments. There are two stacks involved in this deployment, the Jenkins environment and the demo target environment, and you can see those listed in the CloudFormation console here. So the first thing we'll do is jump into the configuration of Jenkins and take a look at the S3 profile that enables Jenkins to place build artifacts into S3. This enables us to take advantage of the highly durable nature of S3 to securely store those artifacts and then pull them down to the deployment instances. Now we've named the S3 profile Jenkins S3, as you can see here, and we're using an IAM role to provide the Jenkins host with a restricted set of AWS credentials. These allow the instance to perform specific actions via the S3 API, and we started the Jenkins instance with that role via the CloudFormation template that we looked at in the last demo. And associated with the IAM role is a policy that defines the permissions that that role inherits. You also have the option of using an IAM user, and in this instance you'll be prompted to provide an access and secret key associated with this IAM user. You can see that here. Now, under no circumstances should you use your AWS root access credentials in this sort of scenario. Always use either an IAM role, which is preferred, or an IAM user with minimal permissions. Here is the policy associated with the IAM role, which we've granted to the Jenkins instance. And you can see that this policy contains two statements with allow effects. Firstly, the statement with the list all my buckets action, which allows the role to list all the S3 buckets in their AWS account. And a second statement which permits any S3 action on the bucket named gm-demo-bucket. And this is the bucket where we're going to place the build artifacts created by Jenkins. We'll now jump over to the build configuration where we've set up the build script as well as the publishing of the artifacts into S3. Taking a quick look at the build, you'll see that we have a last line in the build there which zips up the artifacts into a file called latestbuild.zip. You'll also notice that the S3 publishing configuration is set up to place the completed artifacts into the gm-demo-bucket with an object prefix that contains the job name and the build number. And if we jump over onto the S3 console and take a look at this, you'll see that there are folders there that represent the object prefixes for the builds that have taken place so far, so for builds 9 and 10. And if we drill down inside the build 10 prefix, you'll see that the latest build.zip file is there and that this contains the latest build. The last thing we'll do is take a look at the CloudFormation template that builds the target environment, and you can see in this template that we're using the sources resource to download the zip file that was placed into S3 by Jenkins during that build process. And you can see that the string that contains the object reference for the zip file is being built up using parameters that have been passed into the template. The sources resource will take an archive such as a zip file or a tar file and extract the contents into the folder specified, and in this case that's the demo app folder. The very last step of the demo is to jump onto the EC2 instance created by that CloudFormation template, and if we do that we can show you the contents of this folder, which is the demo app folder. And you can see that this contains the contents of that archive which were created by Jenkins during the build process, deposited on S3 and then pulled down onto our deployment server. And you can see that our sample Rails app is running here, and that concludes this demo. We're now going to move on and take a look at some options that you have for deploying on AWS, some additional AWS tools that can help you manage deployments, and then lastly we'll talk about some best practices for continuous deployment on AWS. So first of all, let's take a look at deployment options, and you essentially have two options that you can adopt when you're deploying EC2 instances onto AWS, static or dynamic. And those two options differ. Static deployments typically based on deploying machine images, Amazon machine images or ARMIs, call them AMIs sometimes. Now this is a packaging mechanism which involves packaging up your entire operating system instance. So it can be time consuming at startup to configure, having to rebuild different operating system images each time you do a deploy. And you're typically working with static configuration, so by definition you have less change management to deal with in the environment. You can contrast this against more dynamic deployment models where you would have a minimal Amazon machine image and use the kind of techniques that we showed you a moment ago of pulling down artifacts and deploying those onto your instance at launch time. This can offer some benefits in the sense that You can create, for example, environment-specific deployment options, which might be triggered using switches in scripts that you develop and deploy onto your instances. But it can also be more time-consuming in the sense that it can take longer to launch an instance, pull down a range of artifacts or packages that might be required to turn that into a functional component of your system, and then activate those packages. And you can add to that the fact that when dealing with CI environments, much of the traditionally time-consuming configuration of static machine images can be automated within the CI environment. And this tends to lead customers that are focusing on continuous deployment on AWS to use static deployment, but that's by no means fixed. You can choose whichever option is most appropriate given your environment, but you just need to consider those options at the point at which you're defining your build model. Some tools that are available from AWS to ease continuous deployment. Now, the first one to focus on is something called AWS OpsWorks, which provides an integrated application management service. So you're creating stacks here that represent your application. Those stacks can differ depending upon which environment they're going to be utilized in. Each one of those stacks will comprise a number of layers, and those layers determine how to set up and configure a set of instances and related resources, which might be, for example, volumes or software components. You then tell OpsWorks where it can find your code and any additional deployment tasks, and from this point onwards, OpsWorks will take care of deploying your app for you. And you can scale your stack based on time or on load, which will essentially add more resources to specified layers within your stack. It also makes it easy to clone your production stack to a different region or to automate workflows that you might need to run for common operational tasks. And there's a variety of other AWS tools available to aid and help you with continuous deployment. We talked there briefly about OpsWorks, and we also have something else called Elastic Beanstalk, which allows you to automate the provision of AWS resources to run applications as simply as deploying code from a version control repository into Beanstalk. Beanstalk will then create EC2 instances with appropriate containers to run that code. It will create auto-scaling groups, it will create elastic load balancers, and it will create data sources if they're required and specified within your application. So a higher level tool for managing deployment. And then at the other end of the spectrum, a couple of DIY tools, one of which we've focused on quite extensively throughout this series, which is AWS CloudFormation. As you'll know by now, that is a templating language plus an execution engine that allows you to define collections of AWS resources within templates, and then have those templates executed by the execution engine and build out those resources as necessary. And we actually recorded another webinar early this year which focused exclusively on CloudFormation, called the CloudFormation Masterclass. If you're interested in exploring more about how you might use CloudFormation, it's well worth looking up that webinar and taking a look at that. And then lastly, I guess the ultimate in control, but also the ultimate in DIY, is your ability to build your environment using EC2 instances, scripting or defining that programmatically using one of the SDKs, the command line, or even the raw AWS API, if that's what you choose to do. And then you get complete control over how your resources are assembled, but obviously you have to do the heavy lifting of defining that in your own right. Chef and CloudFormation are tightly integrated. So CloudFormation is a tool for environment initialization, as you know, and then you can use Chef on top of that for deployment and updates of your applications. And there's much more detail about that on the CloudFormation section of the AWS website. If you visit awsamazon.com/CloudFormation, you can find some best practices guides there for getting started with Chef and CloudFormation. And while we're focusing on the topic of best practices, it's probably worthwhile just digging into a few best practices for continuous deployment on AWS. The first of which is this: if you need to SSH into your servers for deployment, you've probably got an issue with your deployment process. So the idea and ideal is to shoot towards a fully hands-off deployment of the type that we just showed to you, where you're using CloudFormation and maybe some of the other tools that we've briefly touched upon, to enable you to fully automate your deployment process, to go from repo to production without having to SSH or otherwise connect to systems to configure them. So you want to be shooting towards that ideal of a completely hands-off, fully automated deployment process. And secondly, this idea that deployments have to be authorized. If you cast your mind back to that SmugMug hardware device that we showed you earlier in the webinar, you might have noticed there was a key in there. That's a kind of physical key, but similarly you may have an approval loop, should have an approval loop that you need to go through before software can be promoted into production. You need to consider that and make sure that you've got appropriate processes and or tools in place to enable your organization to exercise the right level of control over that deployment process. That can lead you to this, which is an idea that it's important to control who can do what in your AWS account. We provide tools like IAM, it's Identity and Access Management, that allows you to define and exert granular control policies over your AWS account and really restrict who can do what. We've already looked at an example of that in today's demo where we used an IAM role to restrict the permissions granted to that Jenkins instance and restrict it to being able to deposit those build artifacts into S3, but there's very, very much more control available through IAM, and you can lock down not only instance roles, but also the permissions that are granted to individual users within your account. It's definitely something that's worth exploring. So best practice is definitely to use AWS IAM for identity and access management. That's really key. And then lastly, on best practices, you can split your accounts. So you can have different AWS accounts that you might use for different purposes. And there's a couple of reasons you might do this. One of which is to do with security again, with governance and control again. The idea that you can have separate login credentials for each AWS account. In this particular example, you probably would not give your developers any sort of access to your production environment. You would restrict that to your operations team. And your dev and test environment, you could be more permissive about who has rights and roles to perform actions on that account. Second thing you can do with this sort of account separation is you can exercise financial control over your accounts. Now you can relink those using something called consolidated billing. So you could have one master AWS account that is the payer account where all of your resources are billed. That will allow you to do things like share volume discounts or consolidate reserved instances across your accounts. But it also allows you to have separate spend limits, separate spend alarms, and separate visibility of your costs across production and development and test. And again, that's something that very many AWS customers choose to do. So a few best practices for you to consider when thinking about continuous deployment on AWS. As usual, I'd like to close up today's session by pointing you towards a few resources. So visit awsamazon.com/blog/AWS. It's the AWS blog. You can stay up to date with all new service announcements, new features that are being launched on the AWS platform if you go there. That's updated several times a day in many cases. If you want to see a consolidated view of recent changes at AWS and recently launched services, go to aws.amazon.com/new and you can find that list of service launches or feature launches broken down by product and then listed chronologically by date. So that's an excellent resource to use also. And if you want to have a more real-time status update from what AWS are up to, you can follow us at AWS Cloud, which is our global account, where you'll find service launches, news and events, customer case studies and the like from AWS globally. We have a similar account here in the UK called AWS_UKI, also on Twitter, where you can find a feed of pertinent information for AWS customers here in the UK, or maybe in the English language in the European time zone, which includes promotion of our webinar program, other events that we're running over here, many feature launches and relevant case studies for UK and Ireland customers. So please follow us on those social media accounts. As I said, my name's Ian Massingham. If there's anything that you feel we haven't covered adequately during the session today, please feel free to send me a note. You can see my email there, or you can follow me on Twitter and, of course, tweet me any feedback that you might have. Thanks for joining us today.